Hello everyone, I hope you're all well. This is Rashid Khan and you're watching my YouTube channel. This video is all about paper 2. I'll highlight the content that you will need to know for paper 2. Following that, I'll go over the main concepts that you will need to know from topic 8 and topic 9. On paper 2, you will be tested against several concepts from the topics listed on the screen. If you look at the list, you will notice topic 1, called Key Concepts, is common to paper 1 and paper 2. To cover the content on these topics, I will make 2 videos for each topic. First video will highlight the core concept. The second video will be based on exam questions from past years, highlighting how you will extract the data from the questions to apply concepts successfully. Let us have a look at topic 8 and 9. The first part of these topics involves forces transferring energy. Now there are a few equations that you will need to know. One is work done equals F times D. GPE equals M times G times H. KE is equal to half times M times V squared. P equals energy divided by time. So this P stands for power. And the last one is efficiency equals useful over input. This time you will be given these equations, but generally speaking, these equations are not available to students. When it comes to forces transferring energy, there are 2 things that you'll have to keep in mind. Consider this situation. Got 3 locations, 1, 2, and 3. So between 1 and 2, I'm going to assume there is no friction. And between second and third, I'm going to assume there is friction. So if I look at first and second, I can then say at this location it is GPE, at this location it is KE. I can say for 1 to 2, if I assume there is no friction, there will be no losses. I can then say GPE will be equal to KE. I can have 2 equations from here. One will be KE equals M times G times H. And the second equation that I can get from here is GPE is equal to half times M times V squared. Now, in paper, you'll be given this equation, GPE equals M times G times H. These 2 equations are only applicable to this situation because of law of conservation of energy. So they may ask you to calculate the value of GPE here. Once you've calculated the value of GPE here, then they may ask you to work out the value of speed at this location. If that's the case, then this situation will apply. Now let's consider location 2 to 3. So when you're going from 2 to 3, at this location, the person will have KE. At this location, the person comes to rest. So all of the KE has now gone into the surrounding as thermal energy. So I can then say work done will be equal to KE. And if that's the case, then again, I can have 2 equations. The first one coming from here, work done is F times D is equal to KE. And the second equation will be work done equals half times M times V squared. In this case, what they can do is they may give you a value of KE at this location, and they'll give you the braking force, and they'll ask you to work out the distance that this person will travel before he or she comes to rest. So in that case, you'll have to make use of this equation. Or they may give you the value of work that got done on this person, as a result of which this person came to stop. And in this case, they can give you the value of mass. They'll ask you to find the value of speed at this location. If that's the case, then you'll make use of this equation. In the presence of friction, some energy will be lost to the surrounding as wasted energy. So efficiency will play its role. So this equation becomes very important in that case. So you'll need to remember in this case, our input will be fixed. This useful can be changed because we know our output will be in the form of useful and wasted. So if wasted goes down, my useful will increase. And as a result of that, my efficiency will increase. To reduce the wasted energy, what we can do is we can make use of oil on this surface. When you use oil, the friction will reduce, and as a result of that, your wasted will decrease, your useful will increase, and hence my efficiency will increase. The second part of this topic is about rotational effects of forces. When it comes to rotational effects, there are two sections to it. The first one is about levers, and the second one is about gears. Under levers, the first thing that you need to know is the use of equation for calculating moment. So moment about a fixed point is given by the equation moment equals force times distance. You must know that force and distance must be at 90 degrees to each other. Second concept that you will need to know about is the principle of moments. I've given you a diagram here with a wooden bar resting on a pivot. Now this wooden bar is horizontal. For this wooden bar to remain horizontal, this condition must be fulfilled, and that says total clockwise moment must be equal to total anti-clockwise moment. So let's have a look at this diagram again. I've got a force called F2 on the right side. It is at a distance D2 from the fixed point called pivot. So it will make this bar rotate clockwise. I've got another force on the left side, which is F1 at a distance D1 from the pivot. This force will make it rotate anti-clockwise. It says the total clockwise moment must be equal to total. So it says total clockwise moment must be equal to total anti-clockwise moment. To calculate clockwise moment, I'll multiply F2 with D2. That's what I've got here. To calculate anti-clockwise moment, I'll have to multiply F1 with D1, and I'll have that. Now in your exam, out of these four, 3 will be given to you, and you'll be asked to find the fourth one. When it comes to the gears, there's an equation that you will need to know, and that is speed of gear A times size of gear A must be equal to speed of gear B times size of gear B. This equation may not be given to you in exam, so you'll have to make sure you know and remember this equation. So the speed will be, these are revolutions per minute or seconds. That's per minute. Size will be the number of teeth on a gear. If you use this equation, you can work out either the speed of one of the gears or the size of one of the gears, provided the other three values are given to you. From this topic, we need to know two more things. First one is about free body diagram. All you need to know about free body diagram is it shows all forces acting on a single object. Let's have a look here. So I've got here two objects. One is this table, and I've got a book resting on this table. Now there's a force acting on this book, and there's a force acting on the table, which is weight. So this is not a free body diagram. However, if I look at this object, now there are two forces acting on it, and they're both on the same object. So this one is free body diagram. The last thing that we need to know from this topic is the vector diagrams. Now we use these vector diagrams to find the resultant force acting on an object. For example, let's say I've got an object here. This object is being acted by two forces. One is 5 Newton and the other one is 3 Newton. The angle between the two forces is 90 degrees. Then they'll give you a scale and they'll say, let's say this 5 Newton force is being represented by 5 centimeters. So this tells me that 1 centimeter represents 1 Newton. The question will ask you to find the resultant force. So what you will need to do in this case is you'll have to either take this force from here and put it there, or you can move this force from this location to there. In my case, I'm going to use the second section where I'm going to move this 5 Newton to this location. So if I move this 5 Newton force to this side, this will appear like this. And then if I join them two together, this will be my resultant force. So you'll have to measure the length of this, and then you will compare. Let's say, for instance, example, I can say the length here is 7 centimeter. So if it is 7 centimeter, that means the resultant force is 7 newtons. This is all that you need to know from this topic. I wish you all very good luck with your exam preparation. Thank you.